Greetings everybody. I'm going to talk today about cranks, wind-up cranks, and these power generating cranks which I found on eBay. I've always been on the lookout for good quality power cranks. I found these on eBay and Amazon and Alibaba.com, and I bought quite a few of them. And these generate 5 volts out of the USB port, so they're basically designed to be plugged straight into your phone or iPad or whatever, or whatever device you have, Nexus. But I found that universally they're rubbish. Like the gears are really made out of really cheap plastic, so as you turn the handle, you hear that? Oh, that connected at the start and then went, oh, funny on me. So yeah, generally they're just rubbish. And see if I can bring it back to life. Nope, the gears are slipping. But then I found these. These generate 12 volts officially. Well, that's what their target voltage is. You can hear it just sounds a lot better, it feels a lot better, feel a lot more well made. If I actually bring in the meter and attach it up, I'll show you what we get out of it using the crocodile clips, which I do struggle to get them attached here because the legs aren't very big. Oh, switch on the meter and we're getting turn on the light so you can see it better. 15, 12, make it up to 20. Just skim 20 there. So, but average is out about 12. And generally, if you were using these in a circuit, you would put something in to actually regulate the voltage coming in. So if it was over 12, it would adjust accordingly. So, yeah, that works. But what I also have, what I also found was these DC to DC boost converters, which ramp up the voltage. And I'm not really sure what I want to use these for, but this one claims that it can take anything from 8 to 30 volts and ramp it up to anything between 15 and 300 volts, which is pretty impressive, really. So yeah, that's how I play around with this and see what we can do with it. What I would actually like to do is see if I can actually power these LED rope lights that are coming off that I use to illuminate my work area. And there is 30 individual LEDs in this rope. It's powered off the mains using a simple switch mode power supply plug here. It takes input of anything from 100 to 240 volts and output to 12. Now the thing is, you say, well, hold on a second, that takes AC. Well, actually, switch mode power supplies you can feed in DC and it'll work just fine. Because when you try to rectify DC to DC, it stays as DC. AC to DC turns into DC. But yeah, but if you feed DC into a rectification circuit, even if it's switch mode power supply or whatever, it works. It won't work with the traditional transformer sort of arrangement, but it will work with the switch mode power supply. Such as the benefits of switch mode power supplies. So yeah, oh, in actual fact, when you feed DC in, when it goes through the half wave or the full wave rectifier, you only effectively use half the circuit because the DC just passes through. Head over to Wikipedia and you'll get all the details. But anyway, so let's have a play around with this. Now what I'm going to do is, first of all, see if I can make this work using my bench power supply. So I'm going to attach the leads are coming out here, and I've used thicker leads for the output because the voltage is getting ramped up. So I'm using green for negative and yellow for positive because that's the only colours I have, and they seem to make sense to me. And here's my switch mode power, my bench power supply leads, and I am going to get my phone and take some video of the display. So here's the bench power supply. I've got the voltage set to 12 but the amp set to 0, and I've also got it circuit open right now. So what I'm going to do is close the circuit, close the circuit, and you'll notice the light starting to flicker because there's a little bit of amperage flowing even when it's off completely. Well, the dial's turned to 0, and what's happening in the boost converter is voltage is flowing in, charging up the capacitors and releasing, but it's not flowing fast enough to keep the lights on continuously. So it's a bit like a toilet in that regard. The cistern fills up and then releases the flush. So if I just start turning the amperage up, once I get to about 30, 35, it stays on. Oh, maybe I need to go towards 40. No, it's happy now. Now this power supply will actually settle on the amperage that the circuit is happily accepting. So if you try to ramp up the amperage, it won't go any further. So it's a safety feature. So there you go. So 30-ish is what 0.3 of an amp is what this boost converter needs to power these lights. So let's see if I can do the same using the hand crank. So what I'm going to do is keep all that connected up. Close the circuit on the power supply. Sorry, open the circuit on the power supply and get the hand crank. So I need some leads. Where are they? So I'm just going to attach negative to the long lead, because that's what I do here. Is I generally make positive shorts, negative long, so that the different lengths makes it less risk of short circuits and the plugs and contacts coming together. So I'll connect that up there, connect that to that, and let's see what happens. Yeah, as you can see, we're getting flashing. And no matter how hard I push it, I can't really avoid it. Have I got another crocodile clip? Sorry, another patch lead. Let's get these out of the way. And I'm going to actually test the current. So I'm going to just attach that to positive and take the yellow off. So I take the yellow off, put it to positive. Take that green. Actually, I'm going to using the worst possible colours for this, but whatever. And bring this in, turn it to milliamps. It's auto ranging, so if it's not right, it'll tell me. And let's see what it says. Let's actually turn the light on. "13 milliamps. So there we go. See if I can push it up. Nah. And also the reason the lights aren't lighting up now, because the meter is actually taking enough current out to actually stop that happening. So yeah, the gist of it is that yes, we can generate a high voltage with this. Unfortunately, we can't generate the current to actually make it useful for stuff like this. I'm not quite sure what I have that I can actually use that generates, or that uses such a low current. See if I can just push it a bit further. Nah, it's not going over 12. So I tried, didn't work. So there we go. What have we learned from this? Well, it's good to play around with electronics. Just don't expect them to work the way you want them to work. Okay, cheerio, bye bye.